The next idea that we want to look at is the principle of inclusion and exclusion. Let's say we have a set X of n objects. Let P1, P2, P3 be some properties of this object that we are looking at. The properties that we are looking at are not mutually exclusive. So it's possible that more than one is satisfied. It's possible that neither is satisfied. So examples include things like we have a set of numbers and one property is divisible by 2, another is divisible by 3. Now it's possible that both are satisfied. It's possible both are not satisfied. Let n of pi denote the objects that are those which have property pi. Note that all we are saying here is that the object has the property pi. We don't care whether it has some other properties or it doesn't have any other properties. Let's look at an example. Let S be the set from 1 through 10. Let P1 be the property that the number is even, P2 be its odd and prime, P3 is that it's prime, and P4 is that it's odd. So let's ask the question, how many numbers do we have that have the property P1, property P2, and so on and so forth. Pause the video here to figure out on your own and then check the answers on the next slide. So the property even is satisfied by 5 numbers, 2, 4, 6, 8, 10. Odd and prime is satisfied by 3 numbers, namely 3, 5, and 7. Just prime is satisfied by 4 because we can now include 2. Just odd is satisfied by 5. Not P3 is satisfied by 6, and so on. We use the notation n of p and q to denote objects that have property p and q simultaneously. We can do the same thing p or q, not p, etc. So we can observe the following. If I wanted to find objects that don't have the property p, then I can first compute all objects that have property p and subtract it from all the objects that I have. If I wanted q and not p, I can look at first objects that have the property q and then from here subtract objects that have simultaneously property p and q. If I wanted to have p and not q, I do exactly the same thing. First find all objects that have the property p and then remove objects that have property p and q. If I wanted p or q, then I can select objects that have property p, that have property q. When I do that, I'm going to count some objects twice. So I should get rid of them, and those objects are the ones that have the property p and q simultaneously. I can continue further. If I wanted to have property not q and not p, then I can take all objects, remove objects that have the property p but not q, remove objects that have the property q but not p, and add n of p and q, which is going to be this expression over here. Note that if you look at these two things, the total number of objects that you're going to have is n, and that's expected because the formulas that are in here are negations of each other. We can extend this to 3 properties, 4 properties, and so on and so forth. One way to visualize this is via this Venn diagram. So this circle represents objects that have the property p. This other circle represents those that have property Q. So n of P and Q are these objects that have both. These are the ones that are outside. And now we can see all the relations that we had on the previous slide using this Venn diagram as well. This is the extension of this for three properties. The one that is of interest most to us is if I wanted to have the property not P, not Q, and not R, then I can start with all the objects, remove objects that have the property P, or property Q, and property R. When I do that, I'm going to remove some objects too many times. So in particular, objects that have the property P and Q, I'm going to remove it here as well as I'm going to remove it from there. So I should go add it back up. And that's why we have added n of P and Q, P and R, Q and R. When we do this, we are going to add some objects too many times, and we are going to subtract that by removing objects that have property P, Q, and R. We can visualize this using this Venn diagram as well. I will ask you to pause the video and see that you can see why this expression is true with the Venn diagram. So here is a summary of some of the things that we got from uh, principle of inclusion and exclusion. We can extend this for more than two properties as well. And these are the applications of that. Note that n is the total number of objects that we have, and capital of N property is the number of objects that have that particular property. What I want you to do here is review this to make sure that you're comfortable with this, and when you apply this, I want you to look at how you're applying this in the examples that we will study in class, as well as some of the examples that are on these slides. Once again, we have reached the check before the go ahead slide. I want to make sure you have understood the role of the Venn diagram in the principle of inclusion and exclusion and how we got the formula for the numbers that satisfy not P and not Q, or numbers that satisfy not P, not Q, and not R. So the Venn diagram should be able to give you an idea of how we got to that rule in terms of how we are doing the counting of addition and subtraction as appropriate.